Dum 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 dum. All right, so Unit 5, Day 6. We're going to be solving compound inequalities joined by and. So today is all about the word and. And means both things have to be true in order for it to be a solution as far as this goes. So what we're going to do is on basically what's going to wind up happening is we're going to wind up with two graphs, and where they overlap is going to be the solution set. So on number 1, we actually graph this piece right here, the x greater than 5, and then we graph x less than or equal to 12. Okay, and we see where they overlap, and then that is the solution set. So we have 5 down here, and it's going to be an open dot, and x is bigger, so we're going to go to the right. And then the other dot is going to be 12 with a closed dot, and x is smaller, so we're going to go to the left. Oops. We're going to go to the left. That way. Okay, now if you notice right in here we've got an overlap. Okay, so we can actually erase our arrows off the ends of this, and that part that I have shaded there is considered the answer set. Now these don't have to be spaced correctly, at least as far as I'm concerned. I just know that 5 is to the left of 12 on the number line, and that works just fine. So on number 2, we're going to have -2 here. We're going to have 1 down here somewhere. 1's going to have an open dot. 2 will have a closed dot. X is bigger than -2, so we go this way. And x is smaller than 1, so we go that way. Okay? And all that stuff between -2 and 1 is an answer. Down here for number 3, we got -3 and 6. That's an open dot and an open dot, and we know that we're going to connect those. Okay? Everything that says and is going to go towards each other. Okay? Now, some of y'all are like, but that doesn't say and. Well, what we can do is we can go -3 less than x, and 6 is less, or x, x is less than 6. And there we have it. So x is less than 6, and x is greater than -3. And there we have it. So we got -4 on this one, and 2. We're going to have an open dot and a closed dot. Connect the two, and there we have it. Okay, this line represents all the numbers between -4 and 2. Alright, now moving on. We're going to write an inequality for the following graphs. On this first one, it starts down here at -1, and it ends at +1. We know that we're going to have an x in the middle. So we know that x has to be bigger than -1, and -1 has a closed dot, so we put a line underneath it. And x has to be smaller than 1, so we put that one. On number 6, we do something much the same. We go 9 and 13. We know that x has to be in the middle. Okay, x has to be smaller than 13, and x has to be bigger than 9. So there's that. Alright, now if some of y'all weren't so great at solving inequalities, don't worry. You get plenty of practice with this. every problem has two problems built in. So on this first one, we're going to go -3 and -3. So that's going to be m greater than or equal to 2. 5 minus 3 is 2. We're going to go -3 on this part and -3 on here. That's going to be m less than 4. So we know that we're going to have 1 down here. We're going to have 1 up here. M is going to have an open dot here and a closed dot here. M is bigger than 2 and m is less than 4. So that way. All right. Number 8 is the exact same thing, except we're going to be doing some subtraction this time and going the other direction. So -6. So 4 minus 6 is -2, less than f. And we got some -6 here. -6. And that's going to be f less than -1. Alright, so I know that -2 is less than -1, so it's going to be to the left of it on the number line. -1 is going to have an open dot. -2 is going to have an open dot, and I just connect them. And there's that. Alright, now with number 9, there's actually multiple ways to do these problems, okay? I'm going to show both ways. Now, this first way is kind of what I consider the fast way, all right? So we subtract 10, just like we normally would, okay? Except we're going to subtract 10 both here and here. So that's 2 minus 10, which is -8, which is going to be less than or equal to -2x, which is less than 8 minus 10, which is -2. And now we're going to divide by -2 everywhere. And it's going to be 4 less than or equal to x less than 1. Now, if you remember correctly, when we divide by a negative, we have to absolutely must change our sign. So now we have greater than or equal to and greater than. So we know that we're going to have a 1 down here. We know there's a 4 up here somewhere. That's going to be a closed dot. And that's going to be an open dot. And now we have to connect those. And that's it. Alright. On number 10, we're going to do, I'm going to show you all the other way to do this. Okay? So basically what we're going to do, if you don't like having to do the same operation like 3 times essentially, and want to stick to just doing it twice, well, we can break this into 2 separate problems. We can go 2 less than 5 minus x, and we can do 5 minus x less than 5. So we can go ahead and subtract 5 from here and here. That's going to be -3 less than -x, divide by -1, and 3 is less than x. 3 is, that doesn't look like a less than. 3 is less than x. And if we remember correctly, we have to switch our sign. So we have to go 3 greater than x because we divided by -1. Now we're going to do pretty much the same thing here for the 5 minus x less than 5. We subtract 5 from both sides. That's -x less than 0. We divide each side by -1, and that's x greater than 0. So we go 0 and 3. It's going to be an open dot and an open dot, and we connect the dots. And there we have it. Okay, number 11. We're going to add 5 everywhere on this one. Add 5. Negative 4 plus 5 is going to be 1 less than x less than or equal to negative 1 plus 5 is 4. Okay? And then there's going to be a 1 and a 4. Close dot. Open dot. And there's that. Now we're going to go ahead and subtract 4 from both sides here. It's going to be negative 10. And then we minus 4 from the other side here. And that's going to be, let's see, negative 10 less than or equal to 2x less than 6. We divide everything by 2. And that's going to be negative 5 less than or equal to x less than 3. So we're going to put a negative 5 here. We're going to put a 3 up here. That's going to be an open dot and a closed dot. And then we connect those dots. And there we have it. All right. All right, and on to the word problems. So, today's temperature is at least 32 degrees. Okay, I prefer to graph things before, sometimes I prefer to graph it before I come up with an equation for it. That's okay. Okay, today's temperature is at least 32 degrees and at most 52. So it means that that did hit 52 and that we got down to 32. That's going to be a closed dot and a closed dot. So that means that F had to be between 32 and 52. And since those are both darkened or closed dots, that means that we got to put our line underneath it. And F is temperature. Temperature. Okay. All right. That's not hard, right? Number 14, a water analysis recommended that the pH level of swimming pool water be between 7.2 and 7.6 inclusive. Write a compound inequality to show the pH levels that are within the recommended range. So let's see, it says to graph the solution and define the variables, or define the variable. So if I were to write an equation for this, I would say 7.2 is less than P, which is less than 7.6. Okay, now here's the thing. We got this funny word in here, inclusive. Okay, inclusive is just a fancy way of saying included. Everything's included. So 7.2 and 7.6 can both be part of that domain or things that we can use. So 7.2 is less than or equal to P, which is less than or equal to 7.6, where P is the pH of the pool. And I just defined the variable. Now all we got to do is graph it. 7.2 and 7.6. If they're inclusive, that means that we're going to have these dark dots. And there it is. Okay, there's our graph. And that part's finished. All right, last question. An iguana needs to live in a warm environment. The temperature in a pet iguana's cage should be between 70 degrees and 95 degrees. There's that funny word again, inclusive. Write a compound inequality to show the temperatures that are within the recommended range. So, compound inequality, 70, needs to be less than or equal to, let's call it T, less than or equal to 95. Alright, so where T is the temperature in Fahrenheit, degrees Fahrenheit. Okay, so the low end is going to be 70, the high end is going to be 95, close dot because it's inclusive, and there we have it. Thanks for watching.